All right, folks, so this is a continuation of yesterday's note where we introduced you to terms like median, right bisector, and altitude. You're going to need to keep those definitions in mind as we work through today's lesson. Much of what we're going to be doing today is essentially doing some proofs. So here in this example, they're telling us that the vertices of a triangle ABC are at these particular coordinates. And so this diagram here, this plot of our triangle, I actually put in, but a question may not put it in for you. So it's important for you, I would say, as a strategy, because some of these proofs are extremely visual. I would have your Instagraphs handy, and I would go ahead and plot any coordinates out to help you visualize the problem. So at any rate, here I've done that for you. We can see that there are, this is obviously a triangle, and the coordinates are plotted out first. So I would also recommend that once you plot out the points, that you label the points as well as the values that are the coordinates as well. That'll just help you to sort out the problem as we move through it. So now here is the question. The question is, if M is the midpoint of AB, so M is the midpoint of AB, and N is the midpoint of AC, verify that MN is parallel to BC. Arg. Okay. So we have a number of things to do here. We're going to first have to find where M is, the actual coordinate, and find where N is. So we're finding the midpoint of AB and we're finding the midpoint of AC, and that is the first thing that we ought to do. So go ahead and pause the video and do that, and I will come back with the solution to that question. Alright, so here you can see that I've calculated the midpoint of line AB, which we're calling point A, or point M rather, and then I've also found point N, which is the midpoint of side AC. So hopefully you got both of those. I'm going to go ahead and plot those coordinates. So at -1 and 0, I'm right here. And I'm going to label that as M, and I'm also going to write out that it's at -1 and 0, just to kind of have that in my face. It also looks like it's the midpoint. So always, use your common sense and say, well, does it really look like it's the midpoint between those two coordinates, those two vertices in this case? And then, let's look at N. So N is at 1 and 4. So 1 and 4 is right here. So I'm going to label that as N and mark it as 1, 4. And that also looks like it's a little bit messy here. It's big point that I've plotted, but it does look like it's at the midpoint. All right, so now let's get to the crux of the question, which is that I have to prove that MN is parallel to BC. So let me draw a line from M to N, and that will be line, oops, I've highlighted it instead of drawn it in, so let me undo that. Here is MN. This would be line MN. And so I'm going to go back and actually highlight those two sides because I think it'll be helpful for us to see them. So here is MN. And I want to know that MN is parallel to BC. And so BC is over here. Right? So the question becomes, what kind of information am I going to use to help me to prove that MN is in fact parallel to BC? Well, I'm hoping that you are thinking about slope, because I don't need the equation of the line, but I do know that if they are parallel, their slopes should be parallel. So let me erase a bunch of this stuff over here because I'm kind of done with it. And then we'll go about doing the second half of the question, which is to prove what I'm actually being asked to prove. All right, so the next thing I need to do is I need to find the slope of MN. So let's go ahead and do that. So I can either use the coordinates or I can count squares, whichever you prefer. I'm going to go ahead and count squares. It looks to me, but actually, you know what? I think maybe we'll just, for the sake of it, we'll go ahead and prove it. So the slope is equal to my y2 minus y1 divided by x2 minus x1. And so going through that calculation, y2 is 4, and I'm going to subtract y1, which is 0, divided by 1 minus negative 1. And so that gives me a value of 4 over 2, which works out to 2. So I know that the slope of mn is 2, and I'm just going to write that in there. And now I need to do the whole same thing, except in this case, I'm going to go ahead and I'm going to do that for, instead of mn, I'm going to do that for BC. So I'm going to erase this little bit here, just to save a little bit of time. And the slope of BC, I'm going to use C as my x2, y2. So 2 take away negative 6 divided by 5 take away 1 will give me 8 divided by 4, which also works out to 2. So there's my 2. So I would make a therefore statement at the end of this, indicating that I actually know what I've figured out. So my therefore statement, I'm going to stick it up in this corner, and I would say, therefore, since the slope of BC and MN are both 2, the lines are parallel. And done. All right. So that's it for that. Let's move on to the next component of this question. So the second half of this question asks that I prove that MN is half the length of BC. So how do I go about knowing the length of these lines? Well, luckily I have the length of a line formula to use, right? So the length of the line, MN, MN, I can find the length of the line by using my length of the line formula. So remember that that looks like this. So I say x2 minus minus x1 all squared plus y2 minus y1 all squared. And then, so I want you to take a minute, go ahead through this calculation, and then check in with me, unpause the video, and I'll have gone through this, I'll have written out the solutions to this, and you can verify that your solution matches mine. Alright, so let's check in for the length of MN. So I can see that the length of MN, when I do my calculations, is 4.5. So I'm actually going to go in and I'm going to write that in. It's roughly 4.5. Of course, I've taken the square root of something that is not going to work out perfectly for me. So I'm going to put in 4.5. Now I'm going to go ahead and get rid of some of this and do the same thing and calculate. Maybe I can find a little bit of room down in here. I think that's what I'll do. And calculate the length of BC. So check in with me in a second. You do your own calculations, and we'll see where we end up. Alright, so when I look at root 80 works out to be, when I don't round, it's like 8.9 something. And so, 4.5 isn't exactly double, but you'll remember that I really rounded this, and it was actually sort of more like 4.47-ish. right? So if I pay a little bit more attention to the number of the significant digits, then I can see that I can comfortably say that BC, the length of BC is twice that of MN, and I've just proved that. Good. All right, let's move on to our next question. So before we begin what I'd like our next section, I would actually like for you to take a few moments to just consolidate some of these skills by trying questions number 1 and 3 in your textbook. Just to firm some of these ideas up first before we move on to the next question. Okay, so we're moving up in the world. This question, I would say, is a lot more involved than the last one, mostly because of the language. So let's break it down. So I'm going to read through it with you. It says the equation of a circle with center at the origin at 0, 0 is x squared plus y squared equals 25. So that information alone tells me that I can plot the graph of this. Remember that the general form of any equation of a circle with its center at the origin, it looks like this: x squared plus y squared equals r squared, which tells me that my radius squared is 25. So if my radius, if my radius squared is 25, then that means the radius of my circle is 5, right? So I can use that information to help me plot my circle on a regular Cartesian plane. So moving on. So next it says the points A, -3 and 4, and B, 5 and 0 are the endpoints of a chord AB. Okay, so I'm going to create a chord by plotting these two coordinates on my circle with radius 5, and they're going to form a chord when I join them. Now it says next, so maybe what I should do is I'm going to actually just move this up, this whole thing, and we'll look at where we are so far. So I've gone to the trouble of plotting this circle, right? I know that the radius is 5, so that means I could go ahead and plot out, plot a coordinate 5 here, 5 here, 5 here, 5 here, and then maybe a couple of other points, and that will create my little circle for me for my diagram. And then I can plot at point A and point B, and then draw that line in representing the chord AB that I was just talking about. So now let's get back to the question, because now that I've created this visual that will help us to work through the question itself, it says DE right bisects the chord AB at F. Yikes. Okay. So let's remember what a right bisector is. A right bisector, you'll remember, is basically a line that bisects or cuts a line in half. But also goes through it at a right angle. So in order to find the right bisector, to do the right bisector, I need to first find the midpoint, because you'll remember that if it's cutting this line in half, then the midpoint I have to find. It looks like the midpoint is here, and then my right bisector will kind of go down here, something like that at a right angle. But I need to prove that. I can't just say it looks like it. I need to actually show that using some math. So I'm going to go ahead and do that. So I need to find the midpoint of AB. That's what I'm going to do right now. And that will be a place to start so that I can get a right bisector in. So you'll remember that the midpoint is going to be, and we call that F. Okay, the question itself called it F. So I'm going to do the same. And I'm going to say, well, the formula to get F is going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Pause the video now. I'd like you to work out this calculation for yourself, and then resume when you're ready. All right, so I'm going to plug these in. So I'm going to choose as my first coordinate A and as my second coordinate B. So x1 is -3 and x2 is 5, so plus 5 divided by 2. And y1 is 4, and I'm going to add that into 0 divided by 2, so I worked that out. And I can tell right now that -3 plus 5 gives me 2 divided by 2, and 4 divided by 2. My midpoint is at 1 and 2. So 1 and 2 is exactly where I thought it would be, right here, but we've proven it now by finding that midpoint. So I'm going to label it F because that is what the question has asked me to do. All right. So now I'm ready to create a right bisector. So there are a couple ways that I can do this. Now I need to think about, well, how am I going to know what that line's going to look like? I can't just use a protractor. I need it to be a little bit more algebraic. And so I'm going to remind you of a couple of things. The first thing I want to remind you of is the fact that perpendicular lines have slopes that are negative reciprocals of each other. So for instance, if I can figure out what the slope is of this thing of AB, line AB, then I know that the slope of my perpendicular bisector, which is I'm just gonna kind of rough it out here, it's gonna be somewhere sort of through here. If I can figure out the slope of AB, then I can find the negative reciprocal of that value and then come up with the slope of my perpendicular bisector and then an equation of the line for that. All right, so that's my plan next. Okay, just so we can keep things straight, I've written a number 1 beside our first step, and now I'm going to do step number 2, which is to find the slope of my perpendicular bisector. Okay. So to do that, what I'm going to do is I'm just going to count squares. Now I could, of course, use the formula y2 or y2 minus y1 over x2 minus x1, but it seems to me that it'll be just quicker if I count squares. So I'm going to go ahead and do that. So I can see that I'm going down by 4 and over by 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So the slope of AB ends up being -4 over 8, which is, I want to reduce that to lowest term, so -1/2. Right? How do I reduce to lowest terms? Well, I know that the top and the bottom can both be divided by 4, so that allows me to reduce that to -1/2. Now I know that the slope of my perpendicular bisector is going to be the negative reciprocal of that. So what is the negative reciprocal of -1 over 2? Well, it is +2 over 1, or just quite simply 2. So there, I figured out that. So now I know the slope of this black line that I've drawn in over here for my perpendicular bisector. The next thing I need to do is I need to come up with an equation for that line and then see if this point 0, 0 actually works for that line. That's where I'm headed. So I'm going to go ahead and do that. So let me give myself a little bit of space here. So I'm going to call this step number 3. And step number 3 I'm going to do right here. So I'm going to say that this is the step where I'm finding the equation. Ugh, my writing is terrible. Of my right bisector. And so I know that I can get any equation of a line in the form y equals mx plus b fairly easily if I know the slope and a point on the line. And lucky for me, I have both those things. Let me see what I mean. Let me show you what I mean. So I know again that I just figured out in the last step that the slope of that line is 2. So I can go ahead and substitute that in for my m values. So 2x plus b. Now another thing that I know is I know that the midpoint, point F, is actually where a point on my right bisector, and it has the coordinates 1 and 2. So I'm just gonna, kind of on the side here, I know that the coordinate F has that 1 and 2. And so that means this is an x value I can sub in, and this is a y value I can sub into this equation in order to solve for b. So that's what I'm going to do next. So subbing in 2 for y, and subbing in 1 for x allows me to work this out. Let me clean this up. So 2 equals 2 plus b. 2 minus 2 equals b. So b in this case is 0. So what does that mean for me? Well, it means, oops, let me just create a little bit of room here. It means that the equation of my line for my right bisector is y equals 2x plus 0, or simply y equals 2x. All right. So now I'm ready for step 4, and this is the final step. So I'm going to say that in this step, it's just subbing in that 0.00 into the equation in order to see if it's a point on the line. So my equation is y equals 2x. That's the equation for my right bisector. And I'm going to sub in 0 for x and 0 for y. So 0 equals 2 times 0. So since 0 equals 0, I can say now for definitively, and this is going to do this up here, therefore, since 0, 0 is a point that satisfies y equals 2x, 0, 0 lies on the right bisector. And ideally, ... of chord AB. So there I go. So that was quite a challenging question with multiple steps. I'm going to suggest that, and I'm going to blow it up here just a second here, I'm going to suggest that you try out these questions right here in class, and that you go ahead and be sure to take this home, give your brain some distance from this instruction, take it home, and try it again when you're not remembering as much of the details, when it's not as fresh, because that will be a true indicator of what you remember and what your problem solving skills are relative to these types of questions. All right, so I know it's a struggle. It's normal for this to feel like it's a lot of work, but keep persevering, keep working through it, and you'll find that it'll pay off. And we'll give us a day when we get back from the March break to practice some of these skills together again and get warmed up to them.